Analysis of group 1 cations. Separation and analysis. Identification of group 1 cations. Through analysis of cations, we are able to separate and identify the components of an unknown mixture. First of all, let's get started with a practical flowchart of group 1 cations. Group 1 cations includes those cations who selectively precipitate as chlorides by addition of diluted hydrochloric acid. These cations are respectively Ag positive, Pb2 positive, and Hg2 positive. If we consider the whole periodic table, the only elements whose chlorides are insoluble are those of silver, lead, and mercury, while chlorides of the other elements are soluble. So what does this mean? That even if inside the unknown substance we have a bunch of different inorganic substances, after the addition of hydrochloride, all the cations Ag plus Pb2 plus Hg2 plus will remain in solution. From a practical viewpoint, the treatment is carried out with 2N-hydrochloric acid, approximately 3 ml. Okay, suppose someone gives you an unknown inorganic substance. How do you find out what's inside? We take the substance and we put it in a test tube. We add 2N-hydrochloride and mix the content of the test tube, stirring with a glass rod. To speed up the process, we work in a hot, not boiling water bath. At the same time, we will dissolve the residue, the unknown substance, and precipitate our insoluble chlorides. Then we cool the test tube under a jet of cold water, rubbing the inner walls with the rod. This last step is necessary to precipitate lead chloride, which is not that insoluble. Lead chloride is a crystalline salt whose formation is encouraged by microholes in the wall, larger surface. Once obtained, the white precipitate of chlorides, the solution is centrifuged and decanted. To separate the precipitate from the supernatant, the precipitate is washed with added water with a few drops of 2N-hydrochloride. This will eliminate impurities in the precipitate without solubilizing again the chlorides. That's why is added with some hydrochloride. Precipitation mechanism. How to precipitate chlorides of group 1 cations. The precipitation of these salts takes place because the abundant release of chlorine-negative ions from hydrochloride in solution allows the overcoming of their solubility product. We are obviously talking about the KSP. We must also ensure a quantitative precipitation. Since we are performing a semi-micro analysis, suppose you have the solution, a concentration of Ag plus equal to 10 negative 2 m. The precipitation of AgCl is quantitative when Ag plus reaches 10 negative 5 m, a non-detectable concentration for this analysis. Then, which is the concentration of chloride ions that makes the precipitation quantitative. Then it follows that, and so a concentration that without any doubt hydrochloride, a strong acid completely dissociated in water guarantees. Furthermore, the low concentration of chloride necessary justifies the use of diluted 2N-hydrochloric acid instead of concentrated one. So why don't we use concentrated hydrochloride in some theory? Diluted hydrochloric acid is more than enough to precipitate the cations group 1 as insoluble chlorides. What would happen if we used concentrated hydrochloric acid? We would probably solubilize them. This is because concentrated hydrochloride promote the formation of soluble chlorine complexes of our salt. As you can see from the scheme, as the concentration of the chloride raises, the soluble complexes formation rate grows. These complexes are soluble because they are electrically charged molecule and therefore efficiently solvated by water molecules through thermodynamically advantageous ion-dipole interactions. Separation of Pb2 plus from Ag2 plus minus Hg2 positive. We have seen that among chlorides precipitates of group 1, the most soluble is lead chloride. His KSP around 10 -5 tells us that it can be dissolved quite easily by dilution. Adding water means lowering the concentration of the constituent cations. Considering Le Chatelier principle, the equilibrium will move to the right, and in this context means that the precipitate will solubilize. Furthermore, the solubility of this species increases with temperature.